warming up. Yeah. All right. So, don't know? Okay. I thought that was a no-no for me. So we're looking at a piece of pizza, right? 8 slices in a Polito's pizza, correct? Okay. So that means that this is 1/8 of the whole 2 pi, which means that this, in terms of radians, would be, how many radians would that angle be? Not 4 pi, that'd be 2 times around. Pi divided by 4. Yep, other way. So it's pi over 4 is the radian measure there. We know that this side is 14, this side is 14, because those are radii of our circle. So then we just have to figure out the arc length. So the arc length is going to be the radius times theta, which is going to be, what is that, 7 pi over 2? Or approximately, new document, new calculator, 7 pi divided by 2 is, should have hit that one, there we go, approximately 10.9956. So that's my arc length. And then to that, we've got to add 14 and 14. So I get the perimeter of our piece of pizza is 38.996 inches. Yes? No? Need some more explanation. Yes? Personally, I think we should all go to Polito's right now and measure. No? Lunchtime. There it is. Couldn't find it. See how good we got. Yesterday. What's your question? Okay.
Wait, no, I'll do that. You know, like the 2 line things?
The 2 line thingies. Seconds?
But like, when I labeled it, I just used those inches. What should I
For this, yes.
Can I do that?
Yes, you can.
Or is it just too confusing?
That's, I'm okay with it because I know that perimeter is a distance, not an angle.
Okay.
Yep. Yep. And then if it was feet, then we won't do 1 line thing, like minutes. Yep, I'm with it. Yep. All right. So you should have watched the video over the weekend that talked about this. You should have this speed chart written down in your notes somewhere. Okay? Okay? If you haven't, you might be a little confused today, and you should go back and watch that video and write this speed chart down, because next week, Tuesday, a week from today, we will be taking a test that will encompass not only degrees, minutes, seconds, decimal degrees, converting radians to degrees to radian, but it will also, the majority of the test will be on this speed chart. Okay? So the conversion that you're going to go in the, if you're going from rotational to angular, or from angular to rotation, the conversion that you are going to want to have memorized is that 1 revolution is the same as 2 pi radians. Okay? Depending on which way you're going is going to depend on if it's 2 pi radians over 1 revolution, or 1 revolution over 2 pi radians, depending on which way on the speed chart you are going. If you are going from angular speed to linear speed, or from linear speed back into angular speed, then you're going to need to know that 1 radian is equal to 1 radius. And that radius will change with each circle, pulley, wheel, whatever it is that you're dealing with. That radius will change. So we can't always just say it's this, but we can say it is 1 radius. Okay. If you are going from linear speed to distance, or if you're going from distance back into linear speed, you have to add in the time factor. If we're going down, you are going to multiply by time. If we are going up, you are going to divide by time. Okay? But you have to add in the time factor into that one. Okay? Fantastic. Okay? Let's talk truck wheels. A truck wheel with a diameter of 36 inches. Zoe, there's your inches thing again, so totally okay with it. Okay? 36 inches rotates at 630 RPM. RPM, remember, is revolutions per minute, which puts us in rotational speed. Okay? Because rotational speed is revolutions over a certain amount of time. We want to find the speed of the truck in miles per hour, which is linear speed, which is all the way down the speed chart. So we are first given the fact that we are traveling, or the wheel is traveling at 630 revolutions per minute. We love factor label method. Love, love, love the factor label method. Because that way, you should know, provided you did all of your conversions right, provided that you know that these are your major conversions, okay? You should by now, being that you are all at least a sophomore in high school, should know that there are 5,280 feet in a mile. That's just something that you should just know, okay? I hope you know that there's 12 inches in 1 foot. Okay? I hope you know that there's 60 seconds in 1 minute, that there's 60 minutes in 1 hour. Okay? If you really wanted to know, there's 3,600 seconds in 1 hour too. Okay? Right? This one inch is 2.54 centimeters. That one's kind of a little on the fringe one. I still have to look that one up every once in a while, on the rare occasion that I use it. Okay? So we need to get to miles per hour. First thing I would do is I would get rid of my minutes. So I know that there are 60 minutes in 1 hour. Because I know that, or because we did that, that means that my minutes are now out of the equation, and I'm in revolutions per hour. Okay? So now I just have to worry about converting revolutions into miles. Okay? Well, so we started at rotational speed. We need to go to angular speed next. So that would be 1 revolution at R. 1 revolution is 2 pi radians. Now I'm in radians per hour. 1 radian of this circle is how many inches? What radius? so that I can get it into linear speed? What would the radius of our circle be? 18 inches. Yep, because the diameter was 36 inches, so the radius then is going to be 18 inches. Now, I'm in inches per hour. Now we can convert inches to miles. 12 inches is 1 foot. I'm in feet per hour. I want to be in miles per hour. So 5,280 feet is 1 mile. And now the only label that I have left at the top is radians are gone, minutes are gone, radians are gone, or excuse me, revolutions are gone, inches gone, feet gone. I've got miles, only one on the bottom, minutes are gone, hours are there, everything else is gone. So I'm in miles per hour, which I would like to be. Okay. So on top, we have 630 times 60 times 2 pi times 18. On the bottom, we have 12 times 5,280. Now, how you go about typing this into the calculator matters. Okay? Because if you don't put 12 times 5,280 in a set of parentheses, you're going to get something way, way different. Okay? You're going to get that you're traveling at well over 10,000 miles an hour. Okay? What do we get when we type this all into the calculator? 473? Yep. If we ever would ask for the exact speed, you would just have to simplify this fraction. And it actually simplifies down to be 9, oops, tap the brakes. It actually simplifies down to be 945 pi over 44. But rare, like 0.2 out of 10 times we'll ask for the exact. Questions, comments, concerns, clarifications? A bike with a 28-inch diameter wheels is racing at a speed of 36 feet per second. How many revolutions per minute are the wheels making? Okay. So we started with 36 feet per second. We want revolutions per minute. And what's your first conversion? Actually, here, before that, let me ask you, what kind of speed are we in? We're in linear speed, right? Yep, because we're in a linear over a time, or a distance over a time. That's a linear speed according to our speed chart. Okay? We need to get to revolutions per time. That's rotational, right? So we got to go all the way up the chart. So the first one is what? What's your first conversion that you want to change out? Maddie, what do you want to go with? Time? You want to convert seconds into what would the conversion be? You sure about that? 60 seconds, because then my seconds cancel out, yes, over 1 minute. Okay? So now I'm in feet per minute. Next conversion. Need to get to revolution. Speed chart says what is the conversion that I'm going to use. What do we got? We got to get to radians, or no, we have to get to revolutions per minute. So we got to go into radians, right? Okay. But what is my radius? 14 what? 14 inches, right? So can I go 14 inches as 1 radian yet? I gotta get feet to inches first. I gotta get it in the same type thing. So I gotta first go that 1 foot is 12 inches. Now we can do what? One radian is 14 inches. Now we can go, what? One revolution is what, Rose? 2 pi radians. My only label left on top is revolutions. My only label left on the bottom is minutes. That's what I want it to be in revolutions per minute. Okay? So on top, I've got 36 times 60 times 12. On the bottom, I've got 14 times 2 pi. Approximately how many revolutions per minute to 3 decimal places? 29 what? I got 294. I was hoping somebody matched me because I didn't have 290. Figure out what you did wrong? Parentheses around these. So you can go divide 14, divide 2. Oh, that's where it went. You got to divide the 2 pi. You got to do divide 2, divide pi. Yep.
I got it.
Now you got it? Yep. I knew it was an easy one. Okay? 2-part question here. Okay? First part is I want you to find what speed the sock is spinning at in the washing machine. The second part that I want you to find, and I gotta go find it here first. The second part that I want you to find is I want you to find what the total distance the sock traveled in if it was spinning for 15 minutes at that speed. Okay? So find me the speed the sock is spinning, miles per hour, and the total distance that the sock went. Alright, so we be spinning at 1,400 revolutions per minute. Okay, so then I like getting rid of my minutes first, so I'm going to go 60 minutes is I should have been an H, 1 hour. Okay, so now I'm in revolutions per hour. Next, we're going to go 1 revolution is 2 pi radians. Then we're going to go the fact that 1 radian is 27 centimeters. Now here's where the funky conversion comes in, because now we've got 2.54 centimeters is 1 inch. So now I'm in inches per hour. If you don't believe me, minutes gone, revolutions gone, radians gone, centimeters gone. So now I'm in inches per hour. That means I'm going to multiply by 12 inches is 1 foot, and 5,280 feet is 1 mile. Because now inches, feet, left with miles per hour. Multiplying all straight across the top, I got 1,400 times 60 times 2 pi times 27 times 1 times 1 times 1 times 1 times 1 times 1 divided by all those ones, 2.54 times 12 times 5,280. I like all those ones there because we just don't have those. There we go. Okay. So we got that, which gives me approximately, what did I say, 88.547 miles per hour. So that sock is moving. Okay. All right. Then, what is the total distance that sock went? Well, you know that it's spinning at, or it's moving at 88.547 miles per hour. And hopefully you left that on your calculator. The more stuff you leave on your calculator, the better. Okay? All right? And then, now here is where we had some, I shouldn't say discrepancies, but some of you saw the shortcut. We could go that 1 hour is 60 minutes, and then we can multiply by 15 minutes. Because that's how long it was. We could do that. Or, in place of this, we could have just divided by 4. Okay? Or multiplied by 1/4. Because 15 minutes is 1/4 of an hour. Okay? Right? Either way, we get approximately, the sock traveled 22 0.137 miles. Now, if you were a little off with that last one, it's probably because you used your rounded 88.547 instead of using the exact one on your calculator. Okay? I don't believe that we have, nope, we don't have any more. So today, I'm going to hand out you the second worksheet for this section. Tomorrow, you'll get another worksheet and an extra credit worksheet. And then on Thursday, you'll get the review worksheet.